Now that we know how to add and subtract real numbers, we're going to look at it in a different format. Today we're going to look at matrices. Our goals are to organize data in a matrix and to add and subtract two matrices. So what exactly is a matrix? It's a rectangular arrangement of numbers into this group of horizontal rows and vertical columns. Each number in the matrix is called either an entry or an element, and the plural of matrix is matrices. Let's take a look at one. Now, we are going to start by naming the size of a matrix or the dimensions of it, and it goes rows by columns. So if I want to name a particular matrix, I'm going to name it by rows by columns. So the columns are the vertical and the rows are the horizontal. So this is now 1, 2, 3 rows by 2 columns. So that's going to be a 3 by 2. My second one, we go by the rows, 2 rows by 1, 2, 3, 4 columns. Now there's something that you need to know. In order to add or subtract matrices, they can only be the same size. So a 3 by 2 can be added or subtracted by a 3 by 2. Let's take a look at one of these. Let's start by naming the size. How many rows? 1, 2, 3. How many columns? 2. And actually, let me just go back for just a second before we start the addition. We should be able to name an entry or element in a particular matrix. So for example, in the one on the left, if I asked you what would be the entry in the second row, second column, that would be 2. If I asked you for the element or entry in row 1, column 2, that would be 3. Looking at the second one, if I asked you for the entry in row 2, column 4, it would be 1/2. So just knowing the position is helpful. So now, as I mentioned, you can only add or subtract matrices of the same size. The first one is a 3 by 2, and if I notice, the second one is also a 3 by 2. That's going to end result with another 3 by 2. So we're going to take a one-to-one correspondence. I'm going to take the element or the entry in row 1, column 1, and add it to its corresponding row 1, column 2. So that's going to be 3 plus 7. Well, 3 plus 7 is just 10. Now we'll go on to the second. You can either go down the row or down the column, or it doesn't matter which way we go, as long as we do the one-to-one correspondence. Here I'm looking at -4 plus a -1, which will give me -5. On to my second row. 8 plus -5 is 3. 6 plus -6, 0. I'm on to my third row. Third row, first column, -2 plus 0 is -2. And 1 plus 4 is 5. Once again, I can add or subtract matrices of the same dimensions, same size. Let's just try another. Again, I'm looking at this. This is a 3 by 2 and another 3 by 2. So knowing the dimensions. One-to-one correspondence. Now I can have, because I'm dealing with real numbers, I can have fractions and decimals in here. This is actually 1/2 plus 1/4, needing a common denominator. That will give me 3/4 and 6. -2 plus 6 is 4. 5/10 plus 3/10, 8/10. Again, the end result is another 3 by 2 matrix. When we get to subtraction, we use our rules of subtraction, which tell us to add the opposite. You can keep everything in your first matrix, and then you would add the opposite of everything in the second. Again, our rule for subtraction is to keep and add the opposite. Now that we have this, we can now do our one-to-one correspondence. -7 plus 4 is -3. 6 plus -2 is 4. 5 plus 2, 7. -3 plus -1, -4. 3 plus -6, -3. And 9 plus a -9, additive inverse is 0. Once again, if I try to add something that looked like this, I cannot do that. This first one is a 2 by 3 matrix, and this one is a 3 by 2. They have the same number of elements in them, but they're not the same dimensions. There's not a one-to-one correspondence, and they cannot be added or subtracted. We'll do a few extra problems in class, but this, again, is just another way of setting up data into this organized system of rows and columns. There are some applications to this that we can look at in the text, and we'll do some more practice in class.